So today, student, Jai Gurudev first, and good morning. Today we are doing crystal field splitting in tetrahedral complexes. So in this one, in tetrahedral complex means what? Metal is here. It is like that. So first of all, the ligands are approaching. In between the axis. In between axis, ligands are approaching in between the axis. Now, when ligands are approaching in between the axis, the orbital present in between axis, orbital that is dxy, dyz, and dzx, energy will be lift. Energy will be lift due to higher repulsion. Now, if I take the octahedral splitting, 2, 3, 4, then 5. 1, 2, 3, 4, 5. It is split it like that. Two orbitals there and 1, 2, 3 there. It is called E level or it is called T2 level for tetrahedral complex. And this energy gap, earlier one is del O, this one is del T. Now, one point, students, your del T value, since ligands are less, del T value is equal to 4 by 9 of del O value. So splitting in octahedral complex is less than 50% of del O value. That is why the del T value is very less, and pairing energy P is found to be always greater than del T value. That is why low spin means spin does not paired up. Spin remains unpaired always. Low spin tetrahedral complexes are rare. So these things you have to understand. What we have learned, again I am telling, that in tetrahedral complex ligands are approaching in between the axis. The orbital, in between the orbital, in between axis dxy, dyz, dzx, their energy will be lift. So the splitting is like that. This dxy, dyz, dzx, this is dx square minus y square dz square. Now this del T value, because in tetrahedral complex 4 ligands are approaching, the repulsion will be less. And this del T value is found to be 4 by 9 of del O value, means del T value is less and pairing energy always remains more than the del T value. That is why low spin complexes in this one is rare. Another point that we require to read, this is called spectrochemical series. Spectrochemical series. It is the arranging ligands with increasing order of del O. Del O or crystal field splitting energy. Because del O is octahedral, tetrahedral also is applicable. In this series you will get that fluorine, chlorine, bromine, iodine, then you will get NH3, En, NO2 negative, Cn negative, CO. This series is called your spectrochemical series. Now after that we have color in CC. Color in coordination compound. The color in coordination compound is due to DD transition. Already we have done in last unit. So if it is like that, one electron is here, you can write the electronic configuration T2G1 Eg0. If you have light or heat energy is given, so one electron from the lower level promoted to the higher level.